My name is Reed Scher.
My name is Anish Agrawal.
My name is Mu Tian.
My name is Dylan Lesher. Go.
Currently, there are over 2.5 billion people living in the world without having access to proper sanitation. This is primarily because of lack of proper clean water, as well as due to the financial situation of the people living in third world countries. Talking to our customers, we found out that the reason they don't have access to sanitation is primarily because of their economic situation, but also very heavily influenced by the lack of water. So then we took into account the customer needs and brought down the few customer needs we were ready to tackle. The first one, as I stated before, is sanitation system needs to be affordable to the customer. The second one, which is the biggest one for our project, is system needs to use less water. And the third one, which is also very important to our project, is that the system needs to be a closed system which can recycle the waste as well. Looking at the customer needs, we then came down to have some design constraints for our project. Since we talked about using less water, we set up a constraint saying that the design needs to use less than 150 cc of water to achieve flushing. The second thing which we focused on was that it has to be cost effective. So we came up with the numbers of $150 for the entire structure of the sanitation system. This is primarily because when we did a competitive analysis, we saw different competitors in the market who were able to achieve a sanitation system in the price range of $200 to $300, which has a very primitive sanitation system and does achieve the process as well. Therefore, we set up a price range of $150. And the third design constraints we came up with is that the system should not have any electrical or plumbing components. This is because if we do have any kind of electrical or plumbing components, it's going to hike up the price, which is then it's not going to be affordable to the people living in the third world countries.
After finding our design constraints as well as our customer needs, we decided to start the process of building each separate component, which we'll talk about one by one.
The toilet gets its water from gray water used after hand washing. The water flows from the water basin into the reservoir, as seen here. This used less than 150 cc's of water.
After the person has deposited the water into the seal and has used the restroom, they simply turn this lever, releasing the water and the waste, and then the counterweight pulls it back up once they let go, sealing in all the pathogens that are in the reservoir.
After the waste leaves the seal, it travels down the slope in the back of the chamber. The point of that slope is to concentrate all of the waste behind the plexiglass, as seen here. The point of the plexiglass is to allow sunlight into the chamber. Sunlight contains UV rays which can neutralize the bacteria, helping to prevent infection of the person using the chamber. Now, letting in sunlight will also heat up the chamber with the intention of dehydrating the waste. Dehydrating the waste prevents the bacteria from getting that moisture, which can also kill them. These two methods will hopefully kill most of the bacteria in the chamber. In order to remove hazardous air and bacteria from the chamber, we wanted a ventilation system. Now, since we aren't using electricity, that ventilation system has to be mechanically driven. That's where we got the idea for a falling weight. Now, the user simply places this mass on the ramp and allows it to fall. That turns the spool to which the rope is connected. A shaft is then driven, and hence the fan turns. When that fan turns, it draws air out of the reservoir, up out of this tubing, and out of the chamber where the person is using the restroom. Now, this is important because when the user turns the seal, allowing their waste to fall into the reservoir, it can release hazardous bacteria into the chamber with the person, possibly infecting them. Now, some of the design features of this, we wanted a ramp here instead of just allowing the mass to free fall, because the mass will increase the amount of time that the weight is falling. If you look here, if you just release the mass by gravity, it falls incredibly quickly. The ramp adds some friction forces, allowing it to fall more slowly.
One go. After looking at component by component of our actual design, we've proven that the constraints as well as the customer needs were met during this project. For instance, we met the 150 cc's of water in the seal, as you could see in the very beginning of the video, as well as primitive supplies were used with wood, simple cement, as well as other plastic bottles and things that we found around. Finally, we made it so there's no electricity or plumbing. This went with our idea for $150 or less for the actual production because of the low economy. Thank you for watching this video. If you have any questions, feel free to ask.